Hey everyone, so in today's video we're going to be looking at another ALEKS problem. This ALEKS problem is about identifying redox reactions. So we're going to see whether the reaction is a redox reaction, and if it is a redox reaction, what is the reducing agent and what is the oxidizing agent. So the first thing that we want to do for these problems is we want to identify the oxidation state of every element in the equation. So first off, we have hydrogen, which we know has a +1 charge, and we have two of them. So that means that we're going to multiply by 2, giving us a total of +2 for our hydrogen. We have a sulfur over here, and the sulfur has to balance out the charge so that this whole thing becomes neutral. So if we have a +2 charge for the hydrogen, then we know that our sulfur is going to have a -2 charge. The oxygen is on its own. It's in its element state. So the charge of the oxygen sitting by itself is just going to be 0. So we can write that down here, 0. On the right side of the equation, we have a lone sulfur. So we know that the charge is going to be 0 for this one. 0. And we have another 2 hydrogen here, which is going to be a +1 charge multiplied by 2. That's going to give us a +2 charge. And then we have an oxygen, which has to balance out that charge. So we know that the oxygen must be -2. So now we have to look at either side of the equation. So on the left side, we have a +2 for hydrogen, a -2 for the sulfur, and a 0 for the oxygen. On the right side, we have a 0 for the sulfur, a +2 for the hydrogen, and a -2 for the oxygen. So notice that our oxygen is going from a state of 0 on the left to a state of -2 on the right. So the key to remembering this is that 0 is a larger number than -2. So you can think of this change as oxygen being reduced. Let me choose a better color. Oxygen being... that's not a better color. Oxygen being reduced, because we're going from a 0 to a -2, a smaller number. Now, we also have sulfur, which is going from a charge of -2 to a charge of 0 on the right. So, because this is gaining charge, this is the term we refer to as the one being oxidized. So sulfur is being oxidized and oxygen is being reduced. So let's rewrite this really quick for simplicity. So we don't care about hydrogen because hydrogen doesn't have a change in state. So we're just going to show here that oxygen is 0 on the right, sulfur is -2. Sorry, oxygen is 0 on the left, sulfur is -2 on the left, and then sulfur is 0 on the right, and oxygen is -2 on the right. So, we can say now that our oxygen is being reduced and our sulfur, sorry, let's draw another one, let's draw it down here. Our sulfur is being oxidized. Now, it's a little confusing. First of all, we know that because there is a change in state, because we have any one of our elements changing their charge, we know that this is, in fact, a redox reaction. It's a little confusing when we get to the reducing agent, because it would be tempting for you to say that the reducing agent is going to be oxygen in this case, but that isn't true. Oxygen is the thing being reduced. So, rather, the thing that is being reduced is going to be the oxidizing agent, and the thing being oxidized is going to be the reducing agent. So, sulfur in this case is being oxidized. So, if we look at the left-hand side of the equation, we see that the thing doing the oxidization is going to be H2S, meaning this is going to be our reducing agent. And then for oxygen, oxygen is the thing being reduced, so we know that oxygen is going to be the oxidizing agent. So O2 is going to be the oxidizing agent. Okay? So, moving on to this one. Like we did before, we're going to see what our charges are for each part of this equation. So H, we know, is +1. There's only one of them. And then we have the polyatomic ion, nitrate. So because H has a value of +1, we know that nitrate, even if you can't remember, nitrate is going to have a value of -1. And if you want to check, you can always go to your polyatomic ions, and we find that under the -1 charge, we can find nitrate. And it has a -1 there. So just in case you wanted to check, you can refer back to your polyatomic ions. So moving on, we have water. We know that H is +1, and we have 2 of them. So this is going to be a +2 charge, and oxygen is going to have a -2 charge to balance that out. On the other side of the equation, we have H3O. This is hydronium, and we see that it's got a net charge of +1. So as usual, H is going to be +1, and we have 3 of them. So that is going to equal +3. And then oxygen has a charge of -2. +3 plus -2 gives us our +1 charge. So that works out. And then we have a lone nitrate polyatomic, and we don't need to know anything for that. We know that nitrate has a -1 charge. So all in all, we have on the left side of the equation, we have hydrogens in a state of +1. We have nitrate in its -1 state, and we have oxygen in its -2 state. On the right, we have our hydrogens in a +1 state, our oxygen in a -2 state, and our nitrates in a -1 state. So what you'll notice is that the states of each individual element aren't changing in this reaction. There's no, oxygen is -2 here, and it is -2 here. It doesn't change, right? Nitrate is -1 here and -1 here. It doesn't change. So because of this, is it a redox reaction? No, it is not a redox reaction. And because it's not a redox reaction, it does not have a reducing agent, and it does not have an oxidizing agent, because there is nothing being reduced or oxidized in that equation. So, moving on, we have this last problem here. So for this, we have copper sulfate. So let's say you don't remember what the charge of sulfate is. Check your polyatomic ions. Again, you want to make sure you have these memorized. But if we check up here, we see that sulfate indeed has a -2 charge. So moving down here, we know that sulfate has a -2 charge. That means copper has to have a +2. Zinc is alone, so it is going to have 0. On the right side, we have zinc sulfate, and we know that sulfate has a -2. And so therefore, because this is a neutral compound, we know that zinc is going to have a +2. And finally, we have copper on its own here, and that's just going to be 0. So if we sum this up, we can see that copper on the left is +2, and copper on the right is 0. So we have something going from a positive +2 charge, and it is going down to 0, which means copper is the thing being reduced. Now, on the other hand, on the left we have zinc with a charge of 0, and on the right we have zinc with a charge of +2. So zinc is going from 0 to +2. It's gaining charge. Because it's gaining charge, it has to be oxidized. It is being oxidized. Okay? So, remember, the thing being oxidized contains the reducing agent. So, if we look here, let's get rid of these around here. So, let's just get rid of all of it. So right here, we have zinc going from 0 to +2. This is oxidized. And because it's oxidized, that means that zinc is our reducing agent. On the other hand, we have copper going from a charge of +2 to a charge of 0. That means it is being reduced. Therefore, that's a symbol for therefore, by the way. Therefore, it is our oxidizing agent. So, is it a redox reaction? Yes, it is. We have a change in oxidation state. What is our oxidizing agent? That would be copper sulfate, CuSO4. And what is our reducing agent? It's going to be zinc. So notice that when we're filling in reducing agent and oxidizing agent, we're always talking about something on the left side of the equation. You're never going to have, something on the right side of the equation being your reducing or oxidizing agent, because this is a reaction. The agent is the thing doing, the reducing agent is the thing doing the oxidizing, right? And the oxidizing agent is the thing doing the reducing. So that just about wraps it up for this video, and I'll see you in the next one.